All right, in the last video, we just went over this graph. And so when I have y equals 2 to the x power, it's going to look something like this. And this happens whenever this base is greater than 1. When the base is greater than 1, it's going to take this shape right here. So here we have y equals 2 to the negative x power. Now I can rewrite this with a positive exponent and call this y equals 1/2 to the x power. I can make this, instead of this being 2 over 1, it's now 1/2, and that makes this exponent here positive, which was this rule right here. If I have a to the negative s power, I can make this s positive by flipping this right here and having the reciprocal of it. So instead of it being a over 1, it is 1 over a. So same thing. All right, so get to graphing. I am going to randomly, but also strategically pick some points to plug in. So I'm going to go -3 to 2 for this graph. Now these are going to be easier at certain times. And so when I am plugging in a negative number, I'm going to use this one right here, because if I have 2 to the negative from this, and then I'm plugging in a -3, negative times -3 is actually just 3. So this is going to equal 8. Same thing here. I've got -2. So this is just 2 squared to give me 4. I've got -1 to make this 2 to the first, so it's 2. Here I have 2 to the -0 power, which is just 2 to the 0 power, which is 1. And now when I start going positive, now I'm going to flip it over here. So now I have 1/2 to the first power, which is 1/2. And 1/2 squared, 1/2 times 1/2 is 1/4. So as this base is 1/2, what's happening here? These are all getting cut in half. So let's plot these points. We've got -3, 8. We have -2, 4. -1, 2. 1, 0. And then 1/2 and 2 1/4. Okay, so kind of like last time, if this is going to keep getting cut in half, you're just going to cut in half, cut in half, cut in half. You're getting closer and closer and closer, but you are never going to be touching this x axis here. So we have another horizontal asymptote at y equals 0. So when I connect my dots, my now smeared dots, I will not cross that x-axis. Now again, of course, it looks like this is getting higher, but it's not really the case, right? It's just I can't draw it accurately. So let's talk about the same domain range and what this function is doing. My domain, and I go from left to right, and so probably looks better on the video. From left to right, we go arrow to arrow. So my domain is -infinity to infinity. Again, I can plug in any number I want into x. My range, as I go from the bottom to the top, the first thing we go to is that asymptote that this is getting closer to. So this is 0 to infinity. And if you notice here, that's exactly what this was here. My domain was -infinity to infinity, and my range was 0 to infinity. So these are, even though they look opposite, They have the same domain and range. Now this one, as you were going from left to right, was always increasing, it's always getting bigger. This one here, as you go from left to right, is always decreasing. So that is the difference between the two. And so you can tell when it looks like this and when it is always decreasing. This is really not in standard form. It's this right here. You want a positive exponent. And so when this base is between 0, I don't know how I want to write this. When the base is in between 0 and 1 is when it's going to look like this. And when the base is in between 0 and 1, it does have to be positive, but when it gets bigger than 1, it's going to look like this right here. So let me go back to Desmos here like I did last video. Here's what we saw last time. They all had that same y-intercept right here at 0, 1, because anytime you put a 0, you get to the first power. And as this got bigger, this got steeper. And when I say this, when the bases got bigger, the exponential got steeper and steeper. When it went less than 2, but still more than 1, you still had an exponential, but it was a lot more shallow of an incline. So now, here is my 1/2 to the x power decreasing. So as this base again gets smaller, right? 1/3 is less than 1/2. I'd rather have half of a pie than a third of a pie. As this gets smaller, the base is also going to get steeper. Now, all of these again have that same y-intercept of 0, 1. So if I was to put some of these even that has a base bigger than 1, you can see they still cross at the same place, because no matter what that exponential is, if you have anything to the 0 power, it's going to equal 1.